You're watching the Intel Network Builders vSummit series. I'm Guy Daniels, Director of Content at TelecomTV. As 5G continues to gain momentum with new deployments and new service delivery around the world, the core has become a vital element for operators to upgrade in order to reach the full promise of the specification. Well, joining me now to discuss how HPE, Red Hat and Intel are making the deployment of a cloud-native 5G network core easier and a competitive advantage for operators are Chandresh Ruparel, Director, 5G and Wireless Core Infrastructure, Network and Edge Group at Intel, David Kiperos, who is Telco Global Solutions Architect, Partner Technologies at Red Hat, and Richard Band, Head of Mobile Core and 5G, the Communications Technology Group at Hewlett-Packard Enterprise. Hello everybody, thank you very much for taking part in our discussion on the 5G network core. Chandresh, let me start by asking you, what brought these three companies together for the 5G core efforts? What challenge were you trying to solve?
So, as Guy, you mentioned earlier, the momentum towards 5G core is continuing to be sustained. And you have larger major carriers now going through their second and third round of deployments, while the next wave carriers are starting to now deploy 5G SA core to really gain true potential of 5G. And hand in hand, there's a multi-year cloud native transition going on along with 5G SA as carriers look for operational efficiency, service agility, and monetization of new services. And the last part, especially, is very crucial here. What's catalyzing and increasing the pace at which carriers are now looking to transition to cloud native are the vertical industry applications on the enterprise side. So, business services side, there's a huge monetization opportunity with 5G. But as with any major transition, I think the transition is fairly complex. This is akin to what we saw with fixed function to NFV, and just several best practices or best known methods gained from that experience as Intel was one of the leaders in driving this transition along with HP and Red Hat. Uh, we saw the need for broad ecosystem investment, and that's what Intel is continuing to do, deep collaboration with carriers to understand their pain points, trends, ensuring that we are contributing to open source communities and industry consortiums, and more importantly, building some robust training programs through Intel Network Builders University. But a very important lesson learned was that the solutions need to be easy to consume and deployable. As you see innovation coming in and the complexity increasing with more options in the market, even with cloud service providers coming in, you have DIY, do-it-yourself options, etc. It's very important that bringing together IT tools and capabilities, multiple layers of stack, and driving automation and other innovative capabilities with CI/CD that really deliver to the cloud native promise is done with very important element in mind. It's not a switch that you can flip. Carriers are still looking to deliver requirements against regulations, KPIs for performance to drive total cost of ownership, service assurance, and so many others, which means deep understanding of telco requirements is very important. And between Intel, HP, and Red Hat, we have decades working with carriers, understanding the nuances of these transitions and their critical requirements. And with that, the question is, as the enterprise services get into high gear and there is monetizable opportunity, how do you drive deployable solutions that include innovation and drive the new KPI requirements while reducing the risk for the carriers? And that's really the problem statement that brought Intel, HP, and Red Hat together to really pull together the decades of experience combined with new age capabilities that deliver service agility, operational efficiency, and the monetization that carriers are looking for.
Okay, so Richard, what has been delivered so far out of this joint effort that Chandresh has just spoken of?
Well, I would say that we've been working and we've been creating value at two levels. First, there's an activity that we've started back in the physical to virtualized network function evolution that Chandras was talking about before. We've been working over the past years to create what we call the telco core blueprints. So we have specifically designed configurations that we validated against the specific requirements of a telecom solution, particularly in this case the core network, and then most in particular the user plane data requirements that are as we know, are quite stringent. So these telco core blueprints have been evolving towards cloud native now, together with Intel and with Red Hat, and we have successfully sold and deployed these in tier one operators pretty much across the world. And as we were saying before, as Chandler was saying, we're now starting to see a next wave of adoption of these solutions. So that's something that we've done, as I said, since the NAV days, and it's been very successful. It's been very good to see how we can work together in an early stage to identify the specifics requirements, and then make sure that at every level of the solution, we're making the adaptations that are necessary so that the end result is meeting the expectations of our partners and of our end customers, the carriers. And the second level that we've been working on is, in the end, the move towards cloud native is a significant disaggregation of the network. Some customers are going to be wanting to do it yourself, select the individual building blocks, including the telco cloud, and then integrate by themselves. Others are looking for something that is more pre-integrated. And so what we have done is we've taken the blueprint, the starting position from the infrastructure, and then worked with network function partners and our own network functions to create a pre-integrated 5G core stack that is fully cloud native and is providing a level of pre-integration that helps the operators navigate this transition towards cloud native, to adopt CI/CD, and achieve the levels of automation that are required to keep the network manageable and to unlock the innovation of 5G.
And David, let's look now at what Red Hat OpenShift adds to this solution. How is the landscape and requirements changing as we go from NFV to cloud native? And what does OpenShift provide to ease this transition?
Yeah, so Red Hat OpenShift in the context of 5G Core is really about filling gaps. So on the one extreme, you have CSPs who have this time-tested traditional model of anything that comes into their network goes through heavy ETE regression testing, performance testing. It's a very long list, right? That's been a proven model for a very long time. And on the other hand, you have the open source, open mindset of, let's call it Kubernetes, which amounts to a source code repository on GitHub with a massive community that supports it and a bunch of other projects that have spun off from that. So you kind of have these two extremes. And when it comes to deploying a 5G core network, OpenShift, and to a larger degree, Red Hat itself acts as kind of a glue between these two approaches. And that's what you'll see in the Intel, Red Hat, and HPE solution is both the E2E testing, the integration component, and the best that open source has to bear together in a single solution. That's what we're talking about here. In terms of NFV, and let's call it XNF and cloud native, an NFV system really isn't just about managing VNFs. It's not just about orchestrating VNFs. It's more akin to an edge-triggered approach to system design, and that's where an event takes place and then the orchestration kicks in and does something with that event, right? So a VNF crashes or dies, and something, the intelligence is outside of that network, goes into the environment and repairs that VNF. So that's kind of the model that's been there for a long time with NFV. When we look at cloud native, it's very different. primarily because it's trying to solve a different problem. So what happens when you launch 2 billion containers in a week, right? You need a different way to think about network virtualization and applications. So the cloud native approach really is a level triggered system, or sometimes called a closed loop system. And the way that works is there's an API engine that's in the center, a hub of all the intelligence. And these components, they reach into the API engine and they sort of ask themselves, what state should I be in? Right? And they work with controllers, with CRDs, and they're able to self-heal. They're able to build themselves if they crash. So as you can see, there are two very different models. So let's talk about XNF. The way that Red Hat helps to ease this transition is in the world of operators, they don't have the luxury of rebuilding their core networks every time a new emerging technology happens in the industry. However, cool the technology is, they have this responsibility of protecting this existing footprint and at the same time looking at emerging tech. So a good example of this is OpenStack and Kubernetes. So OpenStack today is in production in many operators' environments worldwide, and it's been there for a while. But many of these same operators, they also want to trial Kubernetes and do a cloud native approach as well. So where Red Hat, HP, and Intel come together is we can say, let's look at how the cloud native piece can fit side by side, giving you more options. So you can look at the first, and you can also look at the evolution together, and that's where you have Red Hat OpenStack platform and Red Hat OpenShift container platform. That really, it's about bringing a lot of options to the operator and meeting them on their journey wherever they're at, whatever ideas and strategies that they have for a VNF or a CNF. It's really about bringing all these options to them and saying, what's your strategy? And let's bring both to bear to meet the certain use case that they have in mind.
Okay, thank you. And Chandresh, let me come back to you. What would you say are some of the main pain points that we're seeing on this transition to the cloud native core?
So I would like to go back to a couple of things that Richard and David mentioned here that are very important. One is integration. The other one is the nuanced transition from 4G to 5G and from even NFV to cloud native. The fundamental analogy still applies when you look at fixed function to NFV, but the nature of the problems dramatically changes as we look at the efficiency, the fact that there is a highly distributed edge, and you are trying to drive automation and service agility. So when you consider all those aspects, let's look at a few as examples. Performance, for example, right? It's no more just a VM-based performance going from fixed function, which was much more simpler at an appliance level, to now you have NFV, and then going into the cloud native space, it's really performance with containers. And when you add microservices into the mix, you're talking about overheads that are significant. There's latency introduced. How do you implement this in a service mesh? There are quite a few questions around how do you address this in the optimal manner. Similarly, if you look at security, perimeter security and walled garden approach really worked. Now, every element in the network needs to have a very strong security posture, which means whether it is at a platform level, a data security level, or you're talking about overarching capabilities like confidential computing. If you are talking about a service assurance at a network slice level, how do you implement that? And how do you automate that so your response time is much faster, the latency is lower? Power management has a completely changed equation. It's not just about addressing TDP and a central office constraint, but how do you provide sustainability and lower your power consumption at a data center level? So Intel has capability across all of these areas, and we continue to evolve and develop those. But those capabilities have to be fully exposed into the stack and easy to consume. And once again, full integration so that we are taking the carriers one step closer to reducing risk to a deployable solution. So providing, staged multiple options to stage it and make it easier to transition, having fully integrated solutions, and working together as partners so that the entire stack is fully enabled and easy to consume is really crucial, because these are the specific areas where the devil is in the details, right? When you look inside, what are the specific pain points? It's across these vertical areas that the carriers need to deliver value proposition around.
And Richard, can you tell us how HPE's products, services, and capabilities are addressing these cloud-native requirements?
Certainly. Well, we already talked a little bit about on the infrastructure and the ability to build integrated solutions, and this is clearly one part of what HPE can offer. If we speak about the software itself, we have made a decision back when we started to look seriously at 5G a few years ago, and we recognized that the nature of the network was going to be far more dynamic and far more adaptable than previous generations of networks. And we decided to go fully in with the cloud native and actually did what we call a clean sheet architecture. So we started from scratch with a very clear guiding principle, which was, as much as possible, make telecommunications less special. So wherever possible, use standard IT tools and technologies. So the microservice architecture we talked about, but also open source backing services. So a lot of the capabilities that historically we had to build in-house around logging, tracing, security, etc., we could actually find them from the open source community, and then we selected Red Hat OpenShift as our partner to give us the capabilities from a support perspective and the level of preparedness that we needed to make this actually work. So first things first, we decided to do this cloud, this clean sheet approach for our own 5G network functions. Then second, we recognized that with a cloud native architecture, with many of the non-functional elements coming from an open source community, coming from the standard IT industry, we actually have an opportunity to create end-to-end integration with partner network functions at a level that we could not do before. Because now, as we're all adopting, say, Jaeger for tracing, it's possible to do end-to-end tracing across network functions in a multi-vendor environment. So we started to work with partners at the NF level to make sure that we're bringing together, we are aligning on the open source capabilities, and we're doing the adjustments and handshake, if you will, to allow this kind of end-to-end capability. And then finally, we talked a little bit before about the dynamicity of the network, the need to automate. And historically, HPE as a company, we have a very strong footprint in the OSS landscape. And so we've decided to evolve our OSS solutions for what we call the end-to-end automation, which on the one hand is the entire aspect of orchestration and slice management. So our ability to define multiple slices, instantiate them on the fly, and then making sure that information is transmitted to the assurance side of the house, where we are adopting AI, ML technologies to take all the vast amount of information that we're getting from a cloud-native network, compile that, correlate the information, extract the right KPIs, and then inform back to the orchestration layer when there's a need to take action. So for instance, when we detect that quality of service is going down in a specific slice and it's affecting the end customer experience, we're capable of spinning up an additional slice on demand and move the traffic from the failing slice to a new slice. It's actually something that we demonstrated a while ago with Orange, with a small robot application. And I think it's a very good illustration of what 5G is going to enable people to do once we get to that level of automation, that level of dynamicity that we believe cloud native is enabling.
And David, how does this work that the three of you are doing here, how does it scale to other parts of the network, such as edge compute?
So for a while, when people would talk about scale, it was the discussion was scale up, scale out, scale down, and Now I think the discussion in the cloud native context is really about reproducibility and consistency, and how all of this can be done in a programmatic fashion. So really the goal is about having like a foundational blueprint. If you take transport out of it for a minute, let's look at how you can take a foundational blueprint and use that for core, for RAN, for edge, or MEC, for local breakout. How can you keep most of it the same and make minor modifications for the different use cases? And what this allows you to do is it allows you to deploy use cases almost, as opposed to looking at redeploying a full stack every single time that an organization wants to build a new service. They can just say, this is the new use case. Let's call it a cloud edge portfolio that we want to build. And that operator can say, how do we deploy this programmatically through software? They can do that now. They can say, here's our baseline. We know what's out there. It's a foundation. Let's deploy this UPF here. Let's build a cluster with a separate subnet. Let's do local breakout, and let's build out all these cool edge solutions as well, all done through software. I think that's now the scale conversation.
Thank you. Now, we've already covered a lot of ground here, but what other considerations should executives, architects, and engineers take into account when choosing their network infrastructure for their cloud-native 5G core? Chandresh, perhaps I could start by asking you this.
Yeah, I guess the key consideration is, again, they have a significant investment today in the 4G infrastructure, and NFV, and how to stage the transition is very important. Again, I think there are areas that telcos have traditionally provided their value proposition around, and the question is, how do you not compromise on whether it is regulatory compliance, security, assurance, and quality of service while you are delivering this? So how do you capitalize on years of experience that has been sort of developed in the community, in the ecosystem, and make this migration smoother? And what kind of capabilities are available in that integrated solution that Richard and David talked about is very crucial. To give you an example, having the smallest attack surface with capability like SGX or crypto acceleration make a significant difference when you implement the TLS based microservices communication that is highly secure, especially with the HTTP type interfaces. If you are enabling service assurance or power management, is there telemetry capability in the platform that can allow faster health indicators, that allow for a much lower latency QoS model that Richard just talked about? Can you correlate this information with network functions fast enough to be able to respond? And what kind of AI capability do you have built into the system? So when you look at each of these, it is really a combination of IT capabilities and tools, CI/CD, and general cloud native principles combined with the telco specific infrastructure requirements and KPIs that cannot be compromised. And it's really the marriage of two. So in building, in looking for partners and capabilities, I think this is a very important consideration. Otherwise, you can go in the innovation land and not have a deployable solution, or something that is still from the past and is not innovating fast enough to really to meet the market needs.
Thank you. And Richard, are there other considerations that we need to be taken into account?
Well, Chandresh talked about the need to think carefully about the transition strategy, and I fully agree with him. What I see is that in discussions with customers, before talking about the transition strategy, there's another key consideration to be resolved, which is, what do you want to transition to? And fundamentally, I see three options. Option number one is, you stay on an approach where you rely on a single supplier that takes care of most of your network or all of your network. And at that point, you trust that supplier to deliver all the different elements and integrate them together. Because remember, again, we are in a world that is disaggregated. which gives us a lot of benefits in terms of innovation at the individual component level, but somebody needs to integrate a whole lot. So the key question is, how do you do your integration strategy? Do you go to your existing supplier that does entire network and you stay with them? In that case, you have the benefit of having well-known, trusted interface. The downside is, as we've seen in the past, they may not fully adopt the technology direction you want, and obviously you're giving up a lot of control over that technology direction. The alternative approach is to go do it yourself and select the individual capabilities, the individual components, and then assemble this into a solution that is perfectly matching your needs. Obviously, at that point in time, it has very different implications for your organization because you need to build up capabilities in terms of integration that you clearly do not have to bring to the table in the first option. And many customers are challenged by this because this is a capability set that they may not have developed over the past year. And the kind of resources are required are resources that are in demand not just inside the telecommunications industry, but you're actually competing with all kinds of other industries. And then there's the third option, which is the one that we as Hewlett Packard Enterprise are proposing, which is to work with a partner that does a pre-integration of different components. So you're not stuck with a single supplier because you still have some flexibility to choose between the components. But you're not obliged to do everything yourself. So you're benefiting from the work that has been done upstream in terms of pre-integration, in terms of validation, de-risking the solution, and so giving you the right balance between the benefits of disaggregation and the risk and cost associated by doing the integration. So I think that is a key consideration for any operator, which is what is going to be your integration strategy? A single supplier, do it yourself, or a multi-vendor with a trusted partner that will help you along doing this multi-vendor integration.
Thank you. And David, we've spoken at length about infrastructure choice here and the factors we need to take into account. But how does this all help operators and ultimately consumers in realizing the full potential and promise of 5G?
One of the promises of 5G is not just low latency, but end-to-end low latency. That's from the device through to the application. And the application not just being the 5G core application, but the actual workload itself. So I think what's critical to all this is realizing the integration story. Although the hardware and the software is a piece of it, the integration story continues to go up higher into the stack. It's looking to make sure that all the pieces that stand between the device and the actual workload are addressed through a single integration approach.
Thanks, David. And Chandres, we've been talking about these choices, the technology considerations, but as I've said to David, how does this ultimately help operators to realize the full potential of 5G?
So I think a very important statement that David made here is really the end-to-end aspect of it. So there are two elements, right? So there is the end-to-end aspect from a network perspective, and you need to have a quality of service and network slice management across the board, RAN to core or to the cloud actually. And on top of it, you also have a vertical stack pre-integration that Richard talked about. Ultimately, when you do it right, where key capabilities to address some of the domains that I mentioned earlier can be addressed by easy consumption by the network function providers as well as by COSPs to manage their network better, to manage the network slice better, and still avail the benefit of disaggregation, where you have multi-vendor options. When you completely deliver this solution, both from a pre-integrated, lower risk vertical stack, as well as the end-to-end capabilities, it's really at that point a matter of delivering the service agility to monetize new areas, whether it is automation in a manufacturing environment or a warehouse, or it's a healthcare vertical or oil and gas. There are so many new opportunities that are coming up that actually the sky's the limit, because 5G is really revolutionizing how everybody, whether it's consumers or enterprises, really drive a level of efficiency and new capabilities which we have never seen before. So the innovation is really kicking into gear. It's a question of how fast communication service providers can participate in this. And I think having these risk reduction and ecosystem that is sort of thought through and worked and collaborated across others to enable these solutions is going to be very important.
And Richard, let's get your views as to how all this can help realize the potential of 5G.
Yeah, Guy, you've heard me speak about this topic before. You know that my view on this is that 5G as a network is just the first step. So the 5G I do not consider to be a finished product. In the end, in order to achieve the transformation of all different industries that Chandresh was discussing, we need to work with vertical industries to understand their requirements and adapt our solutions to match those. And that means that the network itself needs to have two really important capabilities. It needs to be much faster to innovate. So we need to have ability to innovate in a much more granular fashion, but also to deploy them much faster using technologies like CI/CD. And the other element is automation. That the network itself needs to respond to changes in demand, needs to move workloads around, create slices, etc., etc. And that requires a high degree of automation, not simply to reduce cost, but also to make sure that we are able to respond in time without errors. So for me, cloud native is a key capability, is a technology that allows us to do both, is to speed up the innovation and to achieve a higher degree of automation. And that is really what's ultimately going to allow us to transform all the other industries that we were talking about just before.
Thank you, Richard. Well, I've got a final question for all three of you. And Chandresh, let me start by asking you, what are some of the key next steps in this collaboration? What else can we expect to see moving forward?
I think Richard hinted to it. The goal will be to continue to refine, I guess, the areas of automation, the agility with which the services are being delivered while meeting, all the capabilities. So it's a fairly involved effort, and it's going to take iterations as we go forward with the changing trends on the enterprise application side. To Richard's point, collaboration with vertical industries is going to be very important. As new platform capabilities continue to come out that address the domains that I mentioned, continuing to fully integrate it and making sure that the network functions and the overarching carrier services are able to take advantage of it. That is going to be the continued effort. But the biggest part of it will be ensuring that this is validated with network functions in the ecosystem and is able to demonstrate end-to-end integration as well as the vertical integration to allow for ease of deployment and consumption. I think so from a next step perspective, it's really evolving this, hardening this, and making sure that new innovation capabilities are added in collaboration with vertical industries, especially to address enterprise services.
Thank you, Chandresh. And David, what are some of the next key steps for you?
I would say is making sure that all this technology is following the use cases coming from the enterprise, making sure that we're actually helping people's lives become different as a result of 5G. And if that's the core, if that's RAN, if that's edge, all together, I think bringing these new use cases to bear is what's key. And I think ultimately that's the 5G monetization opportunity for everyone. And I think that's where 5G is going to shine, is in these use cases out to the enterprise.
Thanks, David. And finally, Richard, what can we expect next? What's coming for the collaboration?
Well, I think Chandresh and David mentioned, that first of all, we need to continue the journey in terms of maturity. There's still a lot of work to be done for the telecom industry to fully embrace and fully understand the implications of adopting cloud native. So that's clearly one step. The other one, as David was mentioning, is, and then we need to reach out to the other industries and help them transform. And maybe a third element is the matter of scale. David mentioned this earlier in the conversation. As we go into enterprise, we are finding that there's a lot of opportunity for private networking. And one of the first things that we're seeing very clearly is there's a demand to put an entire network in a box, possibly in a ruggedized enclosure like our Edgeline 8000. And so the ability to scale down and deliver the full value of a 5G network in an extremely small footprint is certainly another area where you can expect more from us.
Always more work to do, which is very exciting. The three of you, thank you very much indeed for joining us on the programme. We'll draw our discussion to a close now. Thank you all for participating. And don't forget to watch the other programmes in this Intel Network Builders vSummit series, as well as the Network Core. The series also takes a detailed look at vRAN, edge and security. For now though, thank you for watching and goodbye.